There we go. Um, yeah, I think. All right. Well, to start things off, I think the first topic is really that there's this barbell effect with AI, where on the one side you have highly complex, large applications like Facebook, and on the other side you have single page web apps. Um, and you can sort of track every piece of software that's used on the internet between those two things. And I think if I'm hearing you correctly from the last few weeks, and in our private group chats, basically the commentary is that the complex applications like Facebook require teams of people, both in the architecture, in the writing of the software, and the delivery and maintenance of it, because the complexity is super high. And in those instances, using AI to write code is not effective because of a variety of reasons that we can get into. In fact, I'd love to hear from you why you think that's the case. And then on the other side, where you have a single page web app or just a single page, like a sales letter or your own bio, where it's just like profile about, here's some product listings that I have. The AIs can shit that out really fast. I personally, if I think about the kind of software that's useful to me, I would say that 90% of the software that would be useful to me are those single page apps.
To you, well, because you
Yeah.
make landing pages for sales, is that why?
Yeah, it makes sales pages, exactly. Landing pages for sales and marketing. You want to test things out. Um,
And what's the like market size of a single page app like that? Like how much
well,
really can you make? Tens of thousands of dollars from it? Like,
so I'll give you an example. We had a page at Synthesis, the landing page, where over a period of about 6 months, we probably spent close to $200,000 on it. And the reason for that is that a really great landing page will convert at like 1 to 2%. And that's just a lot of money for companies, right? It's like to go from 0.2% to 1% is just such a tremendous amount of money. And when you consider all the salaries, all the building of the pages, like Optimizely is a great example. Optimizely, for people who aren't aware, is a Silicon Valley startup that spun out of the Obama campaign in 2008. And basically, they created a one-click way to do A/B testing between websites, where you'd make two versions of the same site, send traffic half to one, half to the other, and then after a period of time, make a decision on which one was better. So they
yeah.
made that whole process of figuring out how to serve what to whom and all this kind of thing very easy. And so then they had like $1 billion business. And just being able to do those A/B testings is super helpful. And I think anything that speeds up running those experiments is a worthwhile investment. And then I also think that a lot of the tooling that I would need in sales is basically, how is our funnel converting? So go to some dashboard and see step 1, step 2, step 3, step 4, and functionally, how is your funnel converting? The software architecture for that is basically, there's beacons that are on web pages. Every time someone loads that beacon, it sends a log line into a database. And then my dashboard is basically an SQL query or other structured query to that database that then displays a number. It's very basic in terms of data goes in, data sits at rest, data is requested, data is displayed. That's not complicated. It's not like Facebook's, Instagram is on the opposite end completely from these apps, and I'll just sort of give a sense.
Yeah. Well, it's not just that it's not complicated, it's that it's the template of that has been done 100 times. The main thing you're adding is different copy on the page, right? A different video.
Exactly, right. So the challenge that a lot of content marketers or marketers in general will have is that the structure of building a web page is not very useful for them to learn. Whereas, what goes on the web page and where it should go is super useful. And multiple billion-dollar businesses have been built that just make moving images around the page easier, and all of the sort of infrastructure for that. Just to give people a sense on the other side. So that like making a web page app that I was talking about, where it's a dashboard, and most SaaS companies are functionally what I just described. Data goes in, data sits at rest, data gets accessed, data gets displayed. That's not how the Instagram feed works. The Instagram feed is probably the most sophisticated usage of data possible, because basically it looks at every single thing that I've ever looked at or interacted with, and then tries to create a representation, a statistical representation based off. So like it'll create metadata for every single piece of content, and then it will correlate how much time I spend with every single metadata tag, so that it can calculate if I show him this thing, he'll be more likely to spend more time on Instagram, which means that I'll be able to show him more ads. And Facebook's original metric, and Joe can get into this, but I didn't work for Facebook, so I can talk about it, was minutes on site, which is basically like we want to maximize how long people are using the system so that we can make the most money by serving them the most engaging ads. And I would say that the system behind that on Instagram is the most sophisticated and best use case of software that I've seen in terms of complexity. Like I've never seen anything more complicated than that. Everything else I think is simpler than the Instagram, and then serving it to billions of people is just really incredible. Very impressive technically. So,
yeah. So, but it's not even just like serving that. I mean, I guess the modern Instagram is pretty simple. The Facebook product, that was quite complicated. There was a lot of pieces to it. There was the profile, there's groups, there's events. It all had to kind of bleed together. Every single thing you did created a newsfeed item. All those newsfeed items had to be ranked and sorted, even though it's so heterogeneous, into one feed. It was very complex. You had people, you had profiles of people, you had pages, which
so was it complex
companies.
or was it just complicated?
It was both. There's a lot of pieces to it.
Yeah. Okay.
Yeah. And it wasn't designed ahead of time. It just kind of people kept bolting things on.
I remember I had a friend, or internet acquaintance, never actually met the person, although friends of mine that we know did go to his wedding, who rewrote like Facebook's PHP a couple of times, starting in 2004, and then 3 more times throughout the company's history. It was always interesting to read his sort of like technical discussion. They made XHP, and then they made node fibers and all this kind of thing just to make it run better. And it's just interesting the history of how these things evolve, right? Because nobody sets out to design the system. It's basic. And then of course, every time your system increases in usage by a factor of 10 to 100, there's a whole different set of problems that show up that you could not possibly have predicted in advance in a meaningful way, right? Like you might have a level system, let's say it's at 100 utilization, and you'll say, okay, these are the next 50 problems that we anticipate if we go to 1,000. But until you go to 1,000, you don't know which 2 or 3 of the 50 actually matter. And then once you go to 1,000, you can do it. And then once you go to 100,000, it's the same thing. And then 1,000,000, it's the same thing. So when you're at 100, trying to predict the technical challenges that you'll have at 1,000,000 are basically impossible. Which is again why when we look at large language models, yeah, sure, you could look at GPT-2, which was sort of the first time that you had a coherent output, and say, oh, this is interesting, but nobody could have predicted that just a few revs later that we would have the level of complexity that we're at. And now, to your point, which is the LLM is just cheating. It's just plagiarizing the solution that it found somewhere in its data set. And Google search is so bad so that we don't even know that the data set is. It's like, now we're like, the LLMs are actually really, really simple. It's basically if somebody else has done it before and it's in the database that the LLM is trained on, then the LLM can come up with the answer. And if someone hasn't come up with that specific solution before, then the LLM just makes garbage. That's essentially where you're at, right? If I'm following.
Yeah, it can also pull in data, like it can do RAG and pull in a repository that's already doing it, and then kind of translate learning from that. So it's not just what it's trained on, I guess, or it could be context.
Okay.
But yeah, is there any other news that happened in the last 2 weeks? I know we didn't do it last week.
There was a lot of news last week. Yeah, I don't know. I think I'm more interested in more theory stuff, but like, what did you? So that was my point. It's basically there's these sort of 2 emerging perspectives. people who write software for complex systems tell us that the LLMs are not useful, and that's probably true because there's just not enough frontier nuance that they're able to understand. And frontier in this case meaning both in the specific problem area, but also in the specific application of that problem within a software program.
Yeah.
And then, of course, on the other side, making these really cheap, shitty, small files is quite easy for it to do. And so we have this, like, it's the best of times, it's the worst of times perspective with large language models. We have all these VCs saying, oh my God, like it makes really cheap, shitty websites really well. And then everybody who's like an artisan is saying, this sucks. It's not helping me with my job. And I think to Elon's point about the rate of improvement, the ability of it to make cheap, shitty websites that are progressively more complex suggests that it will eventually get to where the artisans are, but perhaps not. I don't know.
Yep. Yeah. People had took the rate of improvement of ChatGPT and then GPT-4, and then I guess some of the other improvements that have happened since people started looking at it, and then extrapolated that it's going to take over the world very quickly. And I guess it's not disprovable until it doesn't, I guess.
That seems obviously wrong, though, based on our experience of the last 3 years.
Yeah, I mean, the people who are working on these companies like OpenAI, like, believe it still. Like the guy who's doing SSI, Ilya, he believes it entirely. And he made a ton of progress on building it, what we have now.
Yeah, well, the thing is also Ilya, right? If we go back to the beginning, he was sort of the one who kicked off this entire, we're going to use GPUs and like in the beginning, right? So he has kind of like a founder mentality where he sees the future and he's just inventing a bunch of cool shit along the way to get there. Not super clear that, like, for me, it feels like this has been a false start and we're going to have to retrace. And the specific retracing is that 40% of the training data comes from Reddit. And that just seems obviously wrong.
Yeah, the Reddit stuff gives you some good, interesting data because it's a lot of people asking like, oh, I have a problem with like my coworker. How do I solve this?
Yeah.
And a variety of votes, and it ends up with pretty good answers, actually. A lot of people before ChatGPT were searching Google with Reddit. So they would search like best microwave to buy Reddit, and then Reddit would actually be real humans giving real input. So for whatever reason, Reddit ended up becoming the only place on the internet that had real humans. Everything else is just like SEO spam.
Well, what about Quora? Was Quora also SEO spam?
I don't know. I think Quora was big for a bit, and then it shifted where a lot of people didn't use it. Ended up being a lot of Indian users, so it stopped being like pretty representative. So Reddit ended up being for most people. And I have friends who used it. I mean, Ghislaine Maxwell randomly used it a bunch.
She didn't randomly use it. She was one of the top moderators in the whole company, and probably a non-trivial part of the architecture of the software itself.
And then my other friend, I didn't know he's an anonymous moderator on some random boards that like I wouldn't have expected. And just, yeah, you probably know some people who are big Reddit moderators. You don't know it.
Probably.
And so it ends up being really good content and really relevant. And usually the question that you ask has been asked before because, we're all doing the same kind of human thing. And so it ends up being really helpful. But then you also have a ton of like racist comments on Reddit and teenagers. So training on all of that willy-nilly probably doesn't work so well in long term. Yeah.
I also think based on some of the discussions that we've had previously, like recently, excuse me, that there's just a lot that we haven't really explored in terms of models that we can use to organize this data.
Yeah, we're highly inefficient, obviously, in terms of how we're using, like, look at how much power these things are using, and all they can do, they can't even add numbers, but it takes like a whole data center to train them. Humans can learn to add in using much less data, much less training time, using just a few watts of electricity in the brain. So there's a lot of room to improve the algorithm. Or like you don't need to memorize the whole internet in order to like add two numbers, right? You can just learn from a few examples.
Yeah, I mean, like you don't need to, which number is larger, 0.9 or 0.11. You don't need to train on the entire world's corpus of data in order to make that evaluation.
To memorize every possible number. Yeah, exactly. And the what, it does work. If you memorize every possible question anybody might ask, then you can solve everything that someone might ask, but you won't be able to solve new things that people ask or new architectures, and it's very expensive. So I think that's what people will look back at LLMs are able to do. But it's kind of again, it's impressive how much they're able to mimic what almost looks like thought.
Okay, so what piece of news? That was my agenda point, is that this barbell bifurcation has emerged, and just more support for it. What point would you like to make, and or news?
Yeah, I mean, I'm feeling a bit of some of the. I mean, a lot of our friends are feeling a bit of the issue where they try to get AI to build something and then they get stuck and then it gets into a loop and end up wasting more time. And I felt that the last couple hours actually building something. And sometimes if it's something that it can do it in seconds. And I think really if you can't do it in seconds, you should give up because it's clearly not able to do it. So you want to like avoid going crazy.
Isn't it interesting that there was some model that people were saying was getting lazier? Like there was some eval that people were using where it was like, give me a table of this particular data set, and then it would say, okay, I did this row, this row, this row, and then you can fill out the rest, was sort of the response from the large language model. And people are saying, oh, this is lazy. That's exactly what a human would do. And I wonder if that was sort of an emergent phenomenon where the system recognized that it wasn't actually going to be able to do a good job building the table. And so it just sort of half-assed it and then said, go figure it out. Right? Like to what extent does the system understand? I know it doesn't understand, but to what extent should it be like on the internet? Like, for example, on the internet and in marketing, if something's going to be successful, it's successful immediately. It's very rare that something is successful after a really long time. That's just kind of, very, very rare, right? Where it's, you'd be like, oh no, it's not true, Michael. Like it took 20 years to be an overnight success. It's like when you were an overnight success after 20 years, it was like the thing that you changed 2 days before was the thing that made it work.
Yeah.
Right? Like usually you have an idea, you launch it on the internet. If it doesn't work within 2 weeks, it's a bad idea.
Yeah. Right? Yeah, it depends if you're hitting the right audience. So sorry, 1 second.
Yeah, distribution is important. Okay.
So distribution is important. Yeah.
Everybody's first product is product focused, and then their second company is distribution focused.
That's right. Right.
Always fighting the last war.
The LLM doesn't vibe market. The LLM doesn't vibe distribute. They haven't figured that out yet.
Right. Well, that's why paradoxically it's made humans more valuable in every industry it goes into. Yeah.
And traditional marketing is all dying, and now it's all influencers. It's all like a bunch of like teenagers on TikTok deciding what the next big product is.
So traditional marketing is not dying. It's that the consensus-based pyramidal structures are dying in our society. So it's not functionally like a marketing thing. It's just the way that information flows through the system. It doesn't look like a pyramid anymore. It looks like a connected graph. And you sort of knew this was the case because if you had asked 11-year-olds in the 1960s, what do you want to be when you grow up? They all sort of gave the same answer: CEO, president, astronaut. Those are all the most leveraged positions in a human pyramid. So like an astronaut has 20,000 people below them, and a CEO has hundreds to thousands, and then the president obviously has a whole country. And so you're at the top of that pyramid. Whereas if you've asked 11-year-olds in the last 10, 15 years, what do you want to be when you grow up? They all say the same thing, which is YouTube influencer, which again is reflective not of like a decline in our society, but a recognition of the youth that now that we're in a networked graph where it's sort of like the value accrues to the curators that have the most number of edges. They just want to be like they want to be Dave. Everybody wants to be David Dobrik. Even the billionaires are
David Dobrik? I don't know who that is, but Mr. Beast is what you mean.
Yeah.
He's the king of YouTube.
Yeah, I think I like David.
Joe Rogan before he got acquired by Spotify.
Yeah, David Dobrik, I think is better. Just pick whoever you want who's been canceled. But
It's been canceled. Okay.
yeah, but basically you want to be in this network graph where you sit in the center, and you even see billionaires who traditionally would in the pyramidal structure, if you were a billionaire or pharaoh or whatever you want to call them, you wouldn't be the king or the president or the astronaut. You'd be the guy who's like influencing the president or the astronaut. So that's sort of when you have a bunch of these pyramidal structures together, then there's a group of people above those people, and then on and on and on, until you get to some, 5 guys who basically decide everything in the world. And what you're seeing as a result of this change in information distribution topology is now all the billionaires want to become influencers. So you see, like, they're all running.
The billionaires are following the teenagers.
Yeah, the reason why is because it's not powerful anymore to be what they were before. Like they have to, like, for example, it's very difficult to imagine a future 10, 20, 30 years from now where every political position doesn't start as a campaign online. So like
a TikTok stream, you're saying?
Yeah, like there's a bunch, like there's this
or
guy
a live stream podcast on
so we'll stay
Twitter
away from
LinkedIn.
Trump, but like there's a guy in the EU, I think his name is Phineas, and he's like the most interesting EU bureaucrat. And there are other EU politicians like Conor McGregor, who's running for president. And so what I'm saying is that there's these people that are going to get large followings online, and then they're going to use them.
So we're going to have more celebrity politicians, like
I don't know that they're necessary. So like celebrities, again, is an outdated construct. So there's popularity. So people are more or less popular in a particular subculture, and that's always been the case. But when you say celebrity, I think about people like Kim Kardashian, who are famous for being famous. I don't think that Kim Kardashian is going to be politically relevant in the same way that somebody like Andrew Yang is a great example, right? Like his entire persona is half AstroTurf, and then half like he's legitimately charismatic online and speaks to people in that sort of Reddit way of explaining things in an overly simplistic manner that gets them to like want him to be a political participant. I would not say that Andrew Yang is a celebrity in the same sense that like a Paris Hilton or a Kim Kardashian or a Dua Lipa or one of these kind of people is.
That's what I'm saying. That the new only job left after AI takes all these jobs is influencer, and so not celebrity, but
it's not
kind of having a following.
Yeah. So again, I don't think that it's the only job left. I think there's this conception that comes from a mechanistic understanding of the world, this pyramidal understanding, that you have one person at the top who's really highly agentic, and then there's a million drones below them that just do whatever function that the organizational structure has assigned to them. I don't think that's how the future is going to work. I think what's going to happen is that everyone
is multipolar.
Yeah, but I think, and the graph is so big along so many dimensions that everyone can be the most maximalist node, right? So for whatever it is, there's always going to be one person who's like the best banjo player or bonsai tree maker or whatever, and that scaled to all of humanity with AI, every person is somehow unique in that respect. And maybe,
yeah, I mean,
maybe back to your point, which is that we're not going to have 8 billion people. We're going to have.
I was about to say that.
Yeah, exactly. And maybe it means we're only going to have 8 million people. I don't actually know, and it's so far in the future.
How many things can you have the best of, right? Like how many best banjo players? There are only so many instruments. Once you count all the things, what do we? How many words are there in English language? 100,000. There's 100,000 best of each word. It's not many people, right? It's just a few million people potentially.
That said, I'm constantly stymied whenever I need to do something at the frontier, that there's only very small number of people that can do it. Everywhere that I see,
and they all live in the Bay Area.
Not necessarily,
or at least one of them is in the Bay Area.
Yeah, it does make it easier to connect with people that they live so close to me topographically. But what I was saying is that, for example, I did this thing where I helped out with rare earths, minerals, and magnets situation. So there was a shortage. And because of the work that I'd been doing in the supply chain, I sort of identified the shortage. And the next logical step was we need to tell the government that if they don't change their policy at a fundamental level, many, many, many American manufacturers will have to stop manufacturing because they can't get access to these materials. So how do you tell the government? It's like, well, we need to show up and talk to the government agency that's responsible for this. So it's the Commerce Department. So we went and took a meeting with the Commerce Department when they asked us for feedback and told them our opinion about the magnets specifically. So they knew about rare earths because the defense primes are interested in them. They didn't really understand the magnets, or they were looking for more information. And that meeting had 4 people in it. And my mom gave me a lot of flack because she's like, why are you going to DC and having this meeting at the request of Commerce about the magnets? You know, this was written as an article in the Wall Street Journal, and there's people who work at a lot of companies. And I said, well, because nobody else did the meeting. Because you can ask them, like, well, was somebody else here talking about this issue? No. So we have an issue that affects the entire economy, and the number of people who actually did all the steps to get to the point to actually do something about it was a grand total of 4, which is really crazy when you think about it. And then everywhere that I look, there's always like 1 or 2 people who are actually doing something in that area. And I don't know what.
They're like are the linchpin that's keeping it all together.
So I had this experience in software development, and maybe you did as well. There are a bunch of very small packages that you can find on GitHub that are important for whatever you're trying to build, that are maintained by like one guy. And sometimes that guy dies and then the package doesn't get updated. I mean, it's like really serious. I'm not joking. There's a ton of these open source packages.
Well, there was a recent issue where there was a scandal because one open source package is maintained by a guy and the guy was in Russia. So they were like, oh, our software supply chain is dependent on Russia.
Yeah. I mean, there's
an open source developer that like maintains.
Right.
packages.
And like, if you go to that guy, he's like living in like a bombed out building with graffiti on it. And it's like not like real, you know, it's not like because Russia's sort of an interesting place in that respect. But that's exactly right. Is that there's always like, you'll be at a company that has thousands of people, billions of dollars in revenue. And so I'll give you an example. So there's a bank, very famous bank, millions and millions, tens of millions of people use it. They had a mobile website. There was a just-in-time package that was used to serve that mobile website. And basically there was a security, like basically the TLS certificate expired and then the package stopped getting updated in their website, and then it just failed. And it was a problem that one developer had introduced 2 years earlier. That person left or was fired. And then 2 years later, sort of the clock ran out on all those things. And then the mobile app for that bank was down for like 12 hours. And there was like 50 million users of that particular product. And it was result of like 1 or 2 people who had not done something. And so I feel like everything is that way.
Yeah, it's hard to think about it because there's a lot of things around us. But yeah, it's a lot maintained. What's another good example? Anything you see is like the huge amount of effort by somebody doing, like, again, even the playground that exists. Like, it's a huge amount of effort someone did their whole life for a decade to build that playground. And I think there's a Kurosawa movie about that also.
Well, and it's an power law distribution too, because it's not that if you see a playground, there aren't like a billion people that were involved in some very obscure way. But if you look at the amount of work for a particular thing, it always comes down to some really steep power law where you're like, oh, actually there was one guy who spent 1,000 hours of his life, like as a proportion of his life, it was like a crazy amount. So that playground can exist, even though tangentially, because we're all in an economy, blah, 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 billions of people participated in building that playground. It's just that it was like a tiny fraction of their lives, but that playground specifically was like an entirety of a human's life.
Yeah.
I think about this a lot.
And does AI change any of that? is
I think
AI
I think what
making?
it does is it accelerates the steepening of that power law. So there's less people folding clothes at Abercrombie and Fitch, and more people who are a single person in Russia who's on a a tiny web thing that is important for the entire software supply chain. That's what I think. Because the only value I think is going to accrue to those weird edge cases.
The good thing,
Hello, children.
children are here. We're talking. I'm gonna finish, okay? And then I'll read you a book, okay?
Okay.
Kiss me.
To come with you.
Well, I have to finish and then we read the book. No. Go play. Go play.
All right. What's
Okay.
the next? What's the next thing? What's something that you read? Unless you want to talk about.
Oh yeah, some new, what else news? So let's see. Meta stopped hiring maybe. I know people personally at Meta who are leaving. They're not inspired by Alexander Wang's leadership. They don't
Wait,
think
you
that.
don't mean like the youngest billionaire ever who went on Sean Ryan show and like
Yeah, he's the youngest
did a
billionaire. It
word
must be
vomit
amazing.
for like 3 hours is not a good leader? Shocking.
Yeah, and he said he won't have kids because he wants them to all have Neuralink and something crazy like
Can you
that.
imagine that you're like a 45-year-old who spent 25 years in software development, and then that guy comes in as your boss and he says the craziest shit? I wouldn't want to work for him either. You're like,
Yeah,
okay,
so
so this guy figured out a way to get 1 million Indians to label things manually better than everybody else, and he's supposed to be like this amazing.
Well, I mean, it turns out that that's like a lot of the secret sauce with AI is getting the right data. So it's
Actually, Indians. Yep, I get it.
I think he was using Philippine people, but yeah.
Or Bangladesh. That was like the Amazon Go stores where everyone was like, "Oh my God, this is amazing!" I was like, "Guys, this is a video camera that's being reviewed by people in Asia." They're like, "No way." I'm like, "No,
we built AI that do this." Like, no,
it actually worked. It would be in every store instantly. So
Right.
obviously, it doesn't work
instead of one store. Yeah,
it's in like one store, and I said it's very easy to fix to do like an experiment. You go into the store, you very slowly pick a water up off the shelf, put it in your cart, you check out with it, you get the receipt in like 2 minutes after you walk in. But if you go into the store and you pick something up and put it back and pick it up and put it back and do this like 50 times and then go out, it takes like 45 minutes to get the receipt. And
yeah, so that leads
a
into my
computer
point
system.
about Waymo is the same way. Waymo has very few cars on the road. They're doing very safe little ODDs, and they're not safe, and they're not proven to be safe. They'd only done like a few million miles. They recently crossed 100 million miles driven, which is a lot better, but still not enough. You need billions of miles to prove that Waymo is safe enough. And they also, again, are driving on very safe roads, which would mean we would need tens or hundreds of billions of miles to prove that Waymos are safe enough. So if you get into a Waymo,
literally they can't resolve the sensor fusion problem, and so whenever it rains or there's high precipitation, they just don't drive.
Yeah, they want to launch in New York, but yeah, it's not going to work in the snow and the rain and all that stuff.
It doesn't work in fog, rain, or snow.
It's also not going to work with aggressive pedestrians. So I don't really know what their idea is, but props to them for going for the hard stuff. But they're just not going to be safe enough. They're going to probably run someone over in New York, and it's going to be on the news and very sad. And oh wow.
Well, so again, this gets back to what we were talking about earlier. I remember because you worked at Lyft, you told me about this 3 or 4 years ago. I actually remember in the pandemic, you told me about this problem with the safety with self-driving cars. And
I wrote an essay about it. And
that's what I was saying. And we went through a whole exercise where you were going to send your essay to Congress.
Oh yeah, I did.
Right, and NHTSA.
Yeah, it may have reached some people. There was some changes happening. I think. Yeah, Cruise got shut down.
I don't know that was causally linked, but I do know that the reasons for it
happened a few weeks after. But no, maybe probably not linked.
Yeah, I think it was probably like really expensive and wasn't going to be yielding.
No, I mean I predicted they'd have an accident, and they did a few weeks later, coincidentally on the timing. But that's inevitably going to happen. And I'm predicting Waymo's going to have an accident as well. They're at hundreds of millions of miles. They're not safe enough. They haven't proven safe enough yet. And if they start doing hundreds of millions a year, it's going to cause a problem. It's going to cause accidents. That said, they can probably settle the lawsuits related to it. They do a lot of non-disparagements, NDAs, so they're probably able to pay off like tens of millions to avoid it. Tesla recently lost a court case, $250 million settlement. They could have settled for potentially 60, but they tried to fight it. They lost $250 million for someone who wasn't paying attention driving the Tesla. And that adds up if you're not safe enough. Like you can't afford to do that 100 times.
Well, do you think that Tesla is in a different position that Waymo is in? Because I sort of get the sense that Waymos work about 80% of the time, and then there's a human being that like teleoperates the vehicle for the other 20%, which is why sometimes you'll get stuck in a Waymo and you'll have to wait like half an hour before a human operator shows up and then like unfucks the situation. Do you feel like that's similar with Tesla's full self-driving, or do you think that
you mean the Tesla's pickup service if they're using remote drivers?
Yeah, well, I know they're using humans, and I know that they are saying that they're basically the same ratio of humans to cars as Waymo, which obviously doesn't scale.
As Waymo? So what is the ratio that Waymo has?
I think it's 1:30 or 1:50 or something like that.
Is it? We don't have any data on that for
no, it's been reported. We can go look it up. This is like one of those things you can go look up.
It's been speculated, maybe, but I don't know.
No, I'm almost positive it's been reported for both Waymo and Tesla. There's like a whole community. Hang on, give me a second. I'll do a research. Tell me about something else that you're interested in.
Okay, so let's see. So I think that I have a Tesla. It drives itself very well. It very rarely needs my intervention. The only times I've needed it is like a couple of times there's like a fork in the road that's very close together and it's hard for me to tell which way it's supposed to go. There's a couple of times like the construction work. Usually it solves construction work now, but sometimes it doesn't. Sometimes there's like a lane that goes straight and then it should have gone right to the other lane. But otherwise, it's kind of perfect. So if someone takes over, I think it's pretty rare and pretty easy for them to just jump in and say, nope, go into the right lane. And, here, switch lanes or stop.
I must be different than you because I use my dad's 2022 Model Y. And every time I go on a FSD trip with him, I have an intervention.
Yeah, maybe it depends on where you go. Yeah.
Like I find that it works really, really well, but then there was like a case where there was a flatbed truck that was on the side of the road in the shoulder, and we're getting off the freeway, and that truck was halfway in the lane, and the thing was not moving, and so I felt like we were gonna die. So I took control and moved around the last second.
Yeah, I don't know. I'm on the highway in the Bay, 280. I'm on 101. I'm on the city streets of San Francisco. It's fine. It's going slowly. It's going efficiently. I don't know where you're in suburbs, I guess.
Yeah.
That seems pretty easy too. Nice wide lanes, no pedestrians usually. Weird. And it's like a bad lane change or like down the wrong road?
Usually it's in a transitional zone between like residential and light industrial is where it happens.
Because the lane's not being marked well?
Yes, the lane's not super marked, and then there's like cars weirdly parked everywhere because it's light industrial. I don't know, in San Francisco, there's some areas like that.
There are, yeah. And it does well with that. It's just kind of like
it's 1 to 10.
1 to 10 right now, and they're both at that.
Yeah,
I mean Tesla's
one remote operator for every 10 vehicles in operation.
Tesla's billions of miles a year, so they know like everything that could possibly happen, basically, and can train on it and are training on it. It'll take years for Waymo to get there, and probably they'll be very dangerous the whole way if they get close.
Do you think that they'll cut?
I'm surprised they've gone this far though, so maybe they'll go all the way. I don't know.
Do you think they'll cut bait on Waymo as Tesla's acceleration becomes more apparent?
Because
they do have a training. Their flywheel is bigger and faster than Waymo's.
They'll cut weight on. What does that mean?
So Google does this frequently, but Waymo is, born from them is kind of the same thing where they might have an early edge, but they don't get sort of the way that the data integration works for that particular thing, and so then their rate of improvement is not as steep, and so eventually, like, it becomes super obvious that they won't catch up.
Yeah, I mean that's kind of what happened with Cruise. When will that show up? I'm surprised they've gotten this far. I'm surprised they got to 100 million miles without massive scandal. So that's actually pretty impressive. They're able to do that with so little training data, just with simulation. I think if Tesla can do its rollout faster and faster, then Waymo is going to have to make a decision whether to accelerate prematurely, like Cruise did, and cause a bunch of accidents, or stay slow. But then if they choose to stay slow, then the numbers just will be like, oh, we're screwed. Like they'll be able to pencil in the math and see that they're not going to make it.
Well, I think that decision.
So actually, the most likely thing is going to be what Uber and Cruise did, which is, oh, mathematically, we know we're going to fail. So let's take the gamble on people's lives and push it even faster. They're going to have to force to do it financially until there's a huge accident, and then they can use the accident to blame it on that, and then shut down the program. The same thing. Cruise accelerated too fast, and kind of gambled, thought they were good enough, and obviously never proved it, and then had some major issues, and then had to shut down.
And you think that's the same for like Zoox and all these kind of other companies as well? Like,
they don't have enough data. They just don't have enough data.
Data
Zoox is cool. It's really cool. I think it's awesome that they're designing their own cars. I think that's really awesome. But design your own car doesn't help you figure out these super long tail edge cases that only happens once every billion miles, of like a baby juggling bicycles crossing the street, and then you don't recognize it. You crash into it. Like that's the kind of stuff that you never see, but like, Tesla's seen it a few times.
Well, and do you think that so that would suggest that synthetic data would be the way to go? And so like NVIDIA and all these companies.
Are you gonna have synthetic data that's gonna decide to simulate a baby juggling bicycles?
Well, so that was my question, right? Is that
you never think of that?
Yeah, so it's basically things that would never be thought of.
Yeah. It's just so long tail. Like you can simulate all you want, but you're gonna simulate things that are slightly different from what you've seen that will never happen, because that's the only thing you can think of, something that's slightly different from what you've seen. It's like an LLM. It's like it won't never happen. What enriches an LLM is human data, something that's never been seen before. What enriches a Tesla, what enriches a self-driving car, is real things that the humans are doing that never been seen before. Like a bank robber painting their bank robbing car to look like a cop car or something.
So I am going to say that I've never seen a baby jump out with a juggling, and I'm a
You've
driver.
only driven hundreds of thousands of miles. You haven't.
That's what I'm saying. And so it's basically the idea here that humans can only do so much of this problem, and then statistically it never happens for us, and so we don't get in trouble. But like, it could happen to me, and then I would kill the baby.
Yeah, we are actually quite safe as compared, as you would think, compared to a monkey. Like, just like, it's amazing that a monkey can drive with almost no training. Like, you can drive an 18-wheeler basically perfectly, almost, maybe a little bit of training on the brakes, but like literally with no training. It's amazing. The way that these cars work is they're learning to drive with neural networks based on a massive amount of data, of perception, and all this stuff. And that is just the same way that LLMs work. They're just trying to see everything and learn from everything. And that isn't really driving like a human, but it's going to solve the problem. It's going to have a lower death rate than humans, mostly because humans drive drunk. They weight the scale against them. If you were not drunk, you would actually probably even handle a crazy situation with a baby juggling bicycles. You would figure that out in 100 milliseconds, and then you would avoid it in exactly the right scenario. And yeah, it's something that it's very surprising how good humans are at driving, but it's just we have failure modes that are different from computers. Our failure modes are being drunk, are not being able to look both left and right at the same time. So we're gonna So like a sharp U-turn, and like we decide to do stupid things like a sharp U-turn without having 360-degree vision constantly to make sure that no one's there. And there's just like a few things like that we do, but everything else that's like super crazy popping out, we kind of figure it out and handle it very quickly, depending on reaction times. And but computers, they're just like completely just random, just chugging data, and they don't even understand anything they're seeing. But
So
they
is that the primary issue? Is that we have a theory of mind, and so we create some kind of intuitive theory of something and then act upon it, versus the computer is just literally like, is this in my pattern database? It is. Okay, this is what I'm supposed to do.
theory of mind is more about other people's theory of mind, although that is useful in driving, especially among pedestrians and bicyclists. So like for example, the Uber crash was somebody crossing the middle of the road at night with their bicycle. And Uber's car had never trained on thinking someone would cross the street, not at a crosswalk, with their bicycle at night wearing all black. But humans have probably a theory of mind that some people might do that sometimes, and they would like be aware and pay attention and not and think, oh, maybe someone is crossing, even if they don't have any lights on and have no bright clothes and they're just being dumb. But yeah, the car just kind of like saw something, maybe not, and kept going.
That's what I don't mean theory of mind like a child understands that it's separate from everybody else. I mean theory of mind like there is an intuitive sense that there are objects that exist in the environment, and then they behave with a given understanding of how it is. So like the car is just seeing data, and does that data match its data set? Whereas the human being is not saying, does this data match my data set? It's like, oh, that's this other thing that I recognize. I should consider that it might move in all these different directions or something like that.
Yeah, just the neural nets are able to do, as we see with LLMs, are able to do some of that. They are able to see something and not just recognize patterns, but also have almost like a world model of it. Like if you look at some of the photos editing software, it can rotate an object to see parts of it that you can't see. And that's a bit of like a model, a guess at what is on the other side. But there's limits to that. And the limit is that they don't do a good job of guessing what that is. They need an enormous amount of data, the whole internet, to be able to guess what the other side of that is. Whereas for a human, they only need to look at a couple of, like my daughters who are here, like I can show them a picture of a penguin they've never seen before, and they just learn what a penguin is from one drawing.
Yeah,
and
we
then they
talked
like
about
see
that.
this other type of penguin, and they're like, "That's a penguin." I'm like, "How do you think that looks nothing like this other penguin?" And they're like, "No, that's." They're able to make these connections instantly with one example, and the cars cannot do that, and we're able to do it better with much smaller data. And yeah, we can do that with with hundreds of miles of training. We can drive probably what, like 100 million miles safely, whereas the computer needs hundreds of millions of miles, billions, to really even maybe be that safe. Maybe.
Yeah, it's always kind of interesting, right? Because we're basically taking one algorithm and maximizing it, whereas human beings are, if you're going to say we're made up of algorithms, there's a lot more going
That's
on.
true. That's true.
single-
It's like 100 miles, and we're also learning a bunch of other stuff while we're driving and going and living and talking to the driver teacher. And that's like one small thing we learned in those 40 hours that you learn in driving school.
Yeah, I'm trying to think about that. When I went to driving school, like how many miles did I drive in driving school before I was a good enough driver?
Yeah.
It couldn't have been more than a few hundred miles.
Well, to be fair, you were pretty bad then. Teenagers are the worst, but yeah, mostly in the decision making part.
Yeah, that's where I would say I was bad. I don't think the actual like object avoidance was any better or worse than today.
But the interesting thing is for humans, like we can use, humans are pretty similar. And so you can make some good estimates based on your like GPA and like how old you are, how safe you are actually, and your credit score and things like that. And so that they have a pretty good model of exactly how safe you are. Whereas for a car, we have zero such model. Like this is the first time we've had this algorithm. We have no idea when the LiDAR fails, how often the LiDAR fails, how often the cameras fail, how often it goes berserk or, sees a white truck and thinks it's the sky. We're learning that real time, and there's no model around it. And just looking at it already, we know that it takes hundreds of millions and billions of miles for it to learn. And
That was the other thing that I thought was brilliant about what Elon said is the sensor fusion problem, which is basically if you need 10 billion miles to drive safely with just image sensors, and then you add in LiDAR and radar as well, now you have 3 different things that need billions of miles each and together and in all the various combinations. Because like, what if you're driving on mile 200 million and your radar fails? Now you don't have any training data, right? Like that's kind of what's happening.
yes, yeah, you don't have training data on when that fails. Yeah, the just cameras are way more reliable, much richer. You can actually do a lot more integrating of data over time. The LiDAR is, I mean, I was in charge of LiDAR at the first self-driving car lifted. It is great and amazing, but it just does a few dots every revolution, just a few dots, and then you kind of have to do a lot of magic to try to get something coherent out of it. And it's just also not, because there's it's a very fast spinning device, so everything's a little bit off. And the LiDAR is much more reliable than the radar is the worst. It's very, very noisy. It will constantly say, "Oh, you're about to hit a wall." And what are you going to do?
There was there was a story from Google self-driving. I remember 2011, 2012. It was driving around my neighborhood there in Mountain View. And there was a story that the guys were telling me one day which is that like a plastic bag flew in front of it on the freeway and it like slammed on the brakes at 80 miles an hour because it thought it was going to hit like a solid object.
And that's interesting. That was 100% accurate. There was a solid object right in front of it, in front of the radar. Right, the radar was like, "I'm 100% sure there's a solid object right a feet away from you. You should brake." And what are you gonna do? Like, ignore it or believe it? Like, are you
That's
gonna
what I'm saying, right?
Brake like, every other day?
Yeah,
like,
it's hard to
brake
ignore
every
it.
other day. No, like, no way. And so you need the richer sensor data to actually figure out if anything makes
Well, you have
sense.
to have a concept of a cement block versus a plastic bag.
And a radar is not going to have that, and so you need
neither is a LiDAR, and actually neither is an image camera. You need the neural network behind it to sort of come up with this idea on its own, emergent.
Yeah.
Anyway,
and so you can get a lot of the radar and LiDAR data just from the camera. Like the LiDAR, you get a few points every turn.
I don't like LiDAR because I don't like lasers being shown in my eyes, even if
I also don't like that either.
Every time I see one, I'm always like this, like when I'm driving around. I'm like, I don't want your car to shine infrared light in my eyes. And
that's another thing that's going to become a scandal, probably. I predicted here this will be a scandal. So the cameras, you have every few milliseconds, you get a whole tens of thousands, millions of points of pixels of data every few milliseconds. Boom, 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 boom. 100% rich on the same spot. You have it like 100 times.
Not only that.
Whereas a LiDAR, you're lucky if you hit a tree twice. If there's a tree in front of you, maybe the LiDAR point hits the tree. Or it's invisible. Like it's a thin tree. What are the chances the LiDAR point laser hits exactly that? That's very little.
Yeah. So I have kind of an interesting observation.
So the last thing, go.
Last thing on this was basically I've seen technology now where you can take an image and use math to calculate the wave, to actually capture the 3-dimensional wave of light that comes into the camera into a traditional CCD. And so you can extract depth information from a normal camera. And just with algorithm.
Yeah.
It's basically you have to slightly tweak the I think it's called a Raman filter. It's basically the filter for the light that goes in front of the sensor. You have to slightly tweak it physically, and then use a different set of algorithms. And there's a step down in resolution by a factor of 9. So you go from like a 9 megapixel image to a 1 megapixel image, but then you'll get an exact 3-dimensional shape of that light wave that allows you to infer the distance. And so you can, from any video camera, you can extract like with 100% fidelity up to a certain point, because the light waves degrade, exactly the depth information from it, which I just think is like so cool. So now you have all these cameras and you basically change the supply chain for them just a tiny bit, and now they're all now depth sensing. And the resolution is good enough that you can copy something like this, which is an active infrared illuminator, and then an infrared camera that takes a picture of your face in 3 dimensions, and you can actually just get it straight from the RGB. So you go from active illumination to passive, and you get enough data to do a biometric scan like a face. And so I think that the self-driving cars are going to become extremely accurate in terms of and robots and everything in terms of their depth understanding of the world. And so I actually think,
but perception doesn't matter so much. That's the other thing. Like what you're seeing doesn't matter so much. What matters is what you predict. Where are things gonna be in a second? And that matters a lot more even than where things are now. So perception doesn't matter as much as that. And so, and even that doesn't matter. Like really, you only have 2 inputs, like left and right, gas or brake. That's it. So you really don't have to make so many decisions. And there's like a lot of ways you could get it right. And it's like, so like you just kind of just keep going, and then just sometimes some things happen and you just gotta brake fast enough. And that's about it. Like it's not, in some ways it's like a very easy problem. Yeah. So anyway, we're past time, but
oh, okay. Thanks
Yeah.
everyone.